Let's go JavaScripting! Hi everybody and welcome to another exciting edition of Boring JavaScript. I'm your host, the Virtuoid, aka Mike Smith, and today we're taking a look at the BigInt data type. Yes, it's a new primitive data type that was introduced, I don't know, maybe about a year and a half ago or so. I'm not sure. Either way, we're going to show you exactly what it is, how to use it, and the things that could get you if you're not careful. Want to see how it works? Let's get started. So let's first talk about what a BigInt is. Now, a BigInt allows you to specify a number that is larger than the maximum safe integer that is available within JavaScript. Now, JavaScript stores all of its numbers in a 32-bit, which is 4 bytes physically within memory. So there is a maximum number that you can specify within those 32 bits. And I happen to have that number right here, the maximum safe integer number. So to specify a BigInt, or to be able to tell JavaScript they're using a BigInt, all you have to do is type in your number, which I've done here, and put a letter N at the very end. That's it. There's nothing else. JavaScript sees that, it sits there and says, oh, hey, this is a big integer, which is a primitive data type, and that will become very important that I'll show you here in the next video. So this BigInt now is that huge number, which we'll see here in just a second. This is my maximum safe integer, so let's print those out on the screen and see what happens. Now, don't worry about this verbose thing. This is something I threw together at the last minute here to kind of help split up the numbers and make them look a little bit better. And it's, you know, I'm not proud of the code, but hey, it works. Let's go over to Node. Let's type in Node, BigInt. So the maximum integer you can get is 9 quadrillion, 7 trillion, 199 billion, 254 million, 740,991. The big number that I typed in was 1 quintillion, 234 quadrillion, 567 trillion, 890 billion, 123 million, 456,789. Obviously a lot larger than the maximum safe integer. So now what JavaScript has done is it said, okay, this BigInt number, this really large number, is now considered a BigInt, not an integer, but not a number, but is a BigInt. Now, there are also a couple of different ways we can create large integers. Let me pull those up here, because one of the things you're going to run into is that, you know, that's a very large decimal number. What about if I have no clue what that decimal number is? What if I'm working in octal? What if I'm working in hex? Or what if I'm working in binary? How do I specify big integers that way? It's very easy to do. All you have to do is pass your number as a string to a BigInt constructor. Now, it's not you don't want to say new BigInt there. You just want to say BigInt, kind of almost like a static function there. So I could pass a decimal number here. I could pass a hexadecimal number by putting 0x at the very beginning. I could pass an octal number by putting 0O at the very beginning. And I can even pass a binary number by putting 0B at the beginning. And these numbers here just so happen to be the exact same number that I had up here. So if you're working with hexadecimal numbers, octal numbers, or binary numbers, you can still create your BigInt without having to sit there and manually try to do a conversion over into decimal so you can put that little teeny weeny little n at the very end there. So let's see how this works. Let's flip back over to Node. Let's clear the screen off. Let's go to Node BigInt. And here we go. My number was the same as we had before. In hex, yep, as you can tell, it's exactly the same. Octal, it's exactly the same. And binary, it's exactly the same. So everything is exactly the same there. So that's really all there is to creating BigInts. You can either put the small letter n at the very end of the number, or you can put your number within a string, and it will do its best to try to interpret it as a BigInt number. Now, earlier I mentioned this is a primitive data type, so there are some gotchas you need to be aware of. We'll take a look at those next. So what are some of the gotchas? Well, first of all, BigInt is a primitive data type, so it is not exactly the same as a number. So I'm going to show you a couple of things here that you need to be aware of if you're going to be working with BigInts and numbers at the same time. First of all, numbers and BigInts are not exactly the same. So if you're using strict equality, it's not going to be able to do it. And again, why? Because BigInt is a primitive data type, number is another primitive data type. So if we go over to our node and we type in node, whoops. Yep, see? False. BigInt and numbers are not the same. However, if you are doing a normal equality, which is the two equal signs, or you're doing kind of comparison, which is, less than or equal to or greater than, then you can compare both the numbers and the big int. So in this particular case, I'm doing a big int equals 1, which is a normal. It does a type coercion, so it's going to coerce the big int to a number, or the number to a big int. I'm not sure which one it really coerces to. And those are going to say, hey, I'm correct there. This is also going to do a coercion, so 2n is less than 3. Yeah, it sure enough is. So let's go over to Node and let's take a look at that. Let's clear off the screen. And yep, normal equality is true and the comparing is true. So even that part works. So strict equality, normal equality or comparing, that works. Now this is one of the giant gotchas you're going to have to deal with, is that they cannot share the same equation. So you cannot add a big int and a number together. You can't subtract them. You can't divide them. You can't multiply them. You can't exponentiate them. You can't do anything with them. If you have a big int and a number in the same equation, it's going to die on you. And we can see that if we flip over to Node. Let's clear off our screen. Go to Node, whoops, and boom, shakalaka. There it is. Yep, see? Cannot mix big int and other data types. Use explicit conversions. So if you're working with both numbers and big ints, you can't mix and match them together within equations. That is not a good thing to do. And nor can you use them as arguments to functions. For instance, I got a little simple substring function right here that's going to start with the number 0 and go for 2 and end at the index of number 2 of this particular string. And normally that's okay, except I've got a big int right there. And substring is expecting a regular number. So what's going to happen when you try to put a big int in with your where a regular number is expected? Oops, one thing I forgot to do. Let's flip over real quick. Let's comment out line number 9 so it doesn't blow, so that the wrong example doesn't blow up on us. So let's go to Node, whoops, and boom, crash, tinkle, tinkle, tinkle. There it is. Cannot convert big int value to a number. So then again, if you are sitting there trying to put an argument in a big int argument where a regular number was expected, it's going to blow up on you. Now you can do addition, subtraction, multiplication, division, exponentiation, and modulo, if you are using big ints all over the place. So for instance, I've got a big int here and I've got another big int right there. So this equation will work. But here's the thing: if you're going to do a division that ends up with a fractional part, that fractional part will get taken out. Why? Because it's a big int. It is not a big floating point. It is a big int. So 5 divided by 2 is what? It's 2.5. So should I expect 2.5 to come out? No, because 2.5 is not an integer number. So what's going to actually occur there? Let's clear off the screen. Whoop, I forgot to do the same thing here. Let's kill our old error on line 12 there first. Now let's go over to our Node screen. Let's clear off the screen. Let's go to whoops. Yep, see, it just absolutely truncated it. So 5 divided by 2 is 2.5. Nah, I'm just going to report back 2. So be careful in doing division with big ints. You could start losing some precision because integers are integers. They are not decimals. So I was actually thinking, of all this, well, if I could just do addition, multiplication, subtraction, and division, and I can't pass numbers to, if I can't pass numbers or anything like that to an argument, or big ints to a number, what good can I do with it? Well, how can I make a random number? And that's one of the first things I thought of. Well, okay, how would I make a random number between 1 and a hilariously large number, or 0 and a hilariously large number? I'll show you that next. So let's build a random number generator using a big int. Now our biggest problem here is that the random number generator, which is the math.random method, generates a number, specifically a floating point number. Remember, we cannot mix and match big ints and numbers. So my random seed is going to be my math random. My super big number is the largest number I can possibly get at 128 bits. Which is going to be dynamic. So let's take a look and see what those two numbers will give us. Let's flip over to Node and let's type in Node random. And there they are. Here's my first of all, this giant number. I mean, this thing goes past Decillion, you know, a huge number and everything. But notice this is a regular old number. Big int here, regular number here. So how are we going to get it to work? By doing some fancy coercion. So let's take some code and pop it right there. So what I have to do first of all is I've got to get this number into a big int. So I get it into a big int by using the BigInt function. But the problem is I can't just big int on random seed because random seed is going to be a floating point number between 0 and 1. So if I try to convert it to an integer, it's going to truncate it to 0 all the time. So what are you going to do? Well, we're going to convert it to an integer. So I'm converting it to, I'm multiplying the random seed by 10 to the power of 16 to get myself a really huge, but not very huge number that will then get converted into a big integer. So now my super big number is a big integer. My super random seed is a big integer. So now I can compute the random number. And that will be the super big integer times the super random seed. And then I'm going to divide it by 10 to the 16. And that will basically give me back the original number between 0 and my super big number. Now notice here, I did not use a big int, but here I used the big int. Why? Because again, I cannot mix big ints and numbers together. Here, I'm multiplying a regular number, so I've got to use a regular number here. Here, I'm doing multiplications and divisions by a big int, so I got to use a big int here. And also notice that we're doing we're dividing by this number, so we know we're going to get a decimal portion. What happens to decimal portions of big ints? They get cut off. So let's take a look and see how all that runs. Let's clear off the screen. Go to random, and there we are. Here was our seed, which of course got converted to a big int number. And this is our number between 0 and whatever humongous number that happens to be. Let's run it again. Yep, there it is. There's our number between that number and this number. I mean, I can't even know how to pronounce these particular numbers here. And there's another random number. Now, how do we know? I mean, these numbers are ginormous. How do we know it's between 0 and that particular number? Well, you know, let's do a test. Let's do a quick test just to make sure, you know. You always kind of want to test things, make sure everything's okay. Let's make our super big number, I can't spell tonight, to big number equal to 100n. And that's going to that should now give us a number between 0 and 99. Always. Let's save it. Let's flip over to Node and let's test it out. And 78, 54, 59, 98. Yep, working like a champ. These are random numbers between 0 and 100, or 0 and 99. So that pretty much shows or proves that this particular way of getting a random number is the correct way of getting a random number between 0 and our big giant number here. So that's really the key here, is if you do have to use mathematical functions, which they're all looking for numbers and not big ints, just do whatever you have to do to convert it to a big int before doing whatever calculations you have to do. And it will work like a champ. And that's all there is to using BigInt. I hope you enjoyed our video. Hope I didn't bore you to death. Please make sure you click on the like button below and subscribe to this channel for more updates on Boring JavaScript. Also, go to www.boringjavascript.com to see every video we've ever made, or you can see everything we've done at www.thevirtualvoid.com. Thanks again for watching, and we'll see you later.